In this section, we're going to talk about circles and ellipses. Circles are something you've already seen before, and ellipse is just a more generalized version. So it's kind of like all squares are rectangles, but not all rectangles are squares. Kind of the same idea here. All circles are technically ellipses, but an ellipse doesn't necessarily mean you have a circle, okay? So again, a circle you're used to, this is you have a fixed center point, and then you're looking at all of the points that are a fixed distance from that one. So you have some center point, maybe it's right here. This is always denoted by some h value and then a k value. So h corresponds to the x value and k corresponds to the y value. Then you have that fixed distance, which is called the radius. So that is r. So it's the distance from the center to the edge. Okay. And then you're looking at all points that have that distance, so it creates a uniform circle around it. Okay. So again, if I look at the distance from here to the edge, that is also r. Here to the edge, also that distance r. So we have a standard form for our circle. It just depends on that center and the radius. So you have x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared is the radius squared. And it really just comes from your distance formula, because remember, your distance is the square root of all this. So in this case, that distance is fixed, and we just get rid of that square root, okay? So let's try two examples of this. The first is we want to find the equation of the circle with center -4, 1, and radius 2, and we want to go ahead and graph that circle. So immediately I can jump into writing the equation. It is x minus the x coordinate of the center squared plus y minus the y coordinate squared equals the radius squared. So all that happens is the signs are going to change for the center point. So the equation of our circle is x plus 4 squared plus y minus 1 squared equals 4. To graph it, all you're going to do is start by graphing that center point. So that occurs at -4, which would be 1, 2, 3, 4. And then the y coordinate's +1. So that center value will be right here. Now I want to go out a distance of 2 to find points on the edge of my circle. So if I go to the right 2, that lands me here, down 2, left 2, and up 2. And then we go ahead and connect the dots, and that gives us a good representation of our circle. The center is not actually a point. The only thing that are points are the stuff on the edge, but again, you draw that center to be able to identify it. Okay. For this next one, we want to find the center and the radius of the circle. So unfortunately for us, it's not put in that standard form, so we've got to rewrite it in standard form. So this is going to require that process of completing the square. So what I want to get it is x minus something or plus something, y minus or plus something, and then my radius to the other side. So the very first thing I'm going to do is I'm going to group my x and y terms. Because they're not connected right now. And then we're going to move the constant to the other side, if it's not already. Okay. So if I look, I have x squared and minus 4x. We're going to group those together. And I'm going to give myself a little bit of space. Then we have plus y squared minus 16y. So give ourselves some space in there. And then when we move this constant to the other side, we go ahead and subtract it. So we get negative 32. Okay. Now what I need to do is I need to add a number here so that when I group these, I can write it as x minus or plus something squared. Since that middle term is minus though, it's gonna have to be that we're subtracting something. So the way we're gonna figure out what we need to add is you take this number and divide it by 2, and then you square it. Because really it just comes from, if I were to take, say, x minus 3 squared, remember, you'd have to FOIL this out, so you get x squared, you'd get minus 6x, and plus 9. So you cut this center, or this middle term in half, that gives you negative 3, and you square it to give you 9, because of that perfect square formula. So the second step is we complete the square on both terms. Meaning that we add that middle term over 2 squared, and then we're going to balance. Because we can't just add something, we need to make sure we're doing it to both sides. Okay. So I'm going to go ahead and recopy my equation here. Try to make it so it's a little clean. Now what I need to add for the first spot is this term divided by 2 squared. Okay. Now you could just write that over here because I'm adding it to one side. I need to add it to the other. But I like to clean that up a little bit before I add it. So this would be, we're adding negative 2 squared, which really will be positive 4. So on the left-hand side, I'm adding 4, which means I need to do the same thing on the other side. Now I need to do the same thing with the y terms. So to figure out what we add, we take the negative 16 divided by 2 and square it. So let's simplify that before I add it to the other side. That would be negative 8 squared, which means we're really adding 64. So on this side, I also want to add 64. So that will give me ultimately negative 32, and then we'll add 4 to both of these lines. Okay. Now that I've gone ahead and I've added that thing I needed to and made sure I balanced, the third and final step is to factor and simplify. So if I look at my x terms, that will factor very nicely as x minus 2 squared. And again, you can FOIL that out if you need to, but it's that perfect square formula. So you get the first term, the outer term, the inner term, the last term, and those combine to that middle term. And then we have y minus 8 squared. So again, you get 2 times the product of those when you FOIL it out. And then when I add everything on the other side, negative 32 plus 64 is 32. So adding another 4 to that gives me 36. So this is in a form, we can now find the center and radius of the circle. The center is the opposite of each of those values. So the x coordinate is 2, the y coordinate is 8. And then to find our radius, that value is the square root of 36. So our radius is 6. Again, hopefully this isn't the first time you've seen circles. What we want to extend this to now is the concept of an ellipse. So this is defined a little bit differently, but an ellipse is the set of all points whose sum of distances from 2 fixed points is constant. So what I want to do is I want to draw you a picture and kind of identify all the key parts. An ellipse is basically like a circle that's been flattened in one direction. Okay? So we still have a center, which is right in the middle, but the problem is we have two different distances to that center. You have a short distance here, and then you have a longer distance in this case. But also your ellipse could be elongated in the y direction instead. So your center is smack dab in the middle of either of those two major points. There are two fixed points here, which are what define the edge of this ellipse. And these two fixed points are called the foci. If there's a single one, it's the focus. But the idea is if I take a point on the edge of my ellipse and I look at this distance and I look at this distance, their sum is the same no matter which point I take. So if I look at this point here, the distance from here plus the distance from here is exactly the same. So that's how this ellipse is defined. Okay. So that sum is the same. It makes a nice little triangle going on in here. These values are going to be associated with some value of C. So in this case, this would be a positive value of C, and this would be a negative value of C. Okay? So the foci are going to occur at those 2 points. The center in this specific case is going to be 0, 0. And then we have two axes. So I no longer have a single radius. I have two different distances that define the x and y direction. The longer of these two is called the major axis. And the length of this is going to be 2a. So these endpoints here would be positive a, 0. And this would be negative a, 0. Then the smaller axis is called the minor axis. And the length of this is going to be 2b. So this value up here would be 0b, and this value down here would be 0, negative b. Then there is a connection between these values of a, b, and c. This is what's going to define these conic sections. That's just what ellipses, circles, hyperbolas, which we'll learn very soon, are called. So it's kind of like an anti-Pythagorean theorem. So the value of c squared, which is what deals with the distance from the center to the foci, is going to be a squared minus b squared. So you don't necessarily need to remember this specific formula or be able to recognize which is a and which is b. Just think of this as the bigger value minus the smaller value, because I definitely don't want to end up with a negative value for c squared. Okay. We technically only have two vertices, which are going to be the ones that are the endpoints of the major axis. And then we have standard form for this circle. And in that case, it looks just like a circle. It's going to have the same idea where you have x squared plus y squared, but you now no longer have a radius. So instead we like the number 1 over here. And then underneath each of these is going to be a different value. So x, in this case, because again, the major axis is in that x direction, it's the longer one. The value that goes under x is the distance out to that vertex. So this will end up being a squared. And then what goes under y deals with the distance to the edge of that minor axis. So you end up with b squared. So when you're given the equation, whichever one of these is bigger, tells you immediately which one the major axis is. So again, I don't think you need to draw another example to switch the roles and say you have x squared over b squared plus y squared over a squared. Again, it's all relative and just knowing what these points mean and being able to identify which is the larger of the axes, okay? So let's try some examples of this before we start moving this off of 0, 0. We're going to find the vertices, the foci, the domain, the range, and we're going to graph. You absolutely do not need to do this in any particular order, because I think drawing will help you out a lot while you're finding these components. But immediately I know my center in this case, because it's just x squared and y squared. Just like our circle, we're going to end up subtracting stuff from here. So my center is going to be at 0, 0. Then if I compare these two numbers, I have a larger value under x. So that means my major axis is going to be in that x direction. So what I'm going to do is I'm going to start by drawing the components that I do know, and I'm going to utilize these numbers underneath x and y. So again, those give you the distances you have to go out in each direction from the center. So I need to go out 6 in every direction. So our center HK is going to be right in the middle at the origin, 0, 0. And now this being 25 underneath x tells me I'm going to go out 5 in the x direction. So that would bring me right over here and then right back here. Okay, so this coordinate would be 5, 0. And then the other vertex ends at -5, 0. So immediately I've checked off one of the things that I need to find. My vertices are going to occur at -5, 0, and 5, 0. So go ahead, highlight those because that's one of the key things we needed to find. Then in my y direction, I have to go a distance of 4 because 16 is underneath it. So one y value is up here at 0, 4, and then down here at 0, -4. These again are not vertices, they just help us to be able to get a good graph of this. And then we can go ahead and get the full graph by just connecting the dots. So that at least gives us the graph, and from here you can find the domain and range pretty easily. So the last thing that's left to find are those foci. And again, those foci are going to occur in the direction of that major axis. So they're going to be somewhere on the x-axis. In order to find the foci, we need to find that value of c. So again, this involves the two values under here. So c squared is equal to a squared minus b squared. And again, it's just the larger minus the smaller, because what's underneath x is exactly a squared and b squared. So c squared is going to be 25 minus 16, which gives us 9. So our value of c is going to be 3. So from that center point, I'm going to move a distance of 3 to find the foci. So one will be right here at 3, 0, and then right here at -3, 0. So we have those points now. That is -3, 0, and 3, 0. So that was another piece of information we had to find. Last thing we need is just the domain and the range. And this we just utilize the graph for. So for our domain, the farthest left we go is -5. The furthest right is +5. And then for the range, those y values are trapped between -4 and 4. So that is everything we need to know about this ellipse. So let's try one more of these before we start moving the center point. We're going to find the standard form for the equation of the ellipse with foci at 0 ± 2, where the length of the major axis is 6. So what I'd always recommend to be able to get the form, this is really helpful for circles, for ellipses, for also hyperbolas, is if you're given information, graph it. So what I want to do is I want to start by getting an idea as what's going on. So if I consider that my y values are going to be important here, I have one foci here at +2 and -2. And then I'll go out a little more in each direction just so I get a better feel for this, okay? So I have a foci there and a foci at the bottom. That tells me my center is in the middle of these foci. So immediately our center is going to be 0, 0. And then I also know that because the foci occur in the vertical direction, the major axis is going to be vertical. Okay. And so that tells us the larger value is going to be underneath y. Then I also know that the length of my major axis is 6. So starting from that center point, I need to go out a distance of 3. So one end will be here, the other end will be here. Okay. So since the major axis is 6, the major axis is length 6. The distance from the center is 3. Or the distance from the center to the vertices is 3. So immediately you could also pick off what the vertices are if you needed them. They would be at 0, 3 and at 0, -3. Okay. So this also tells me what value has to be underneath y. That will be exactly 3. And again, it's going to end up being squared. So really what's it going to go under y squared is 9. So all I need to figure out is what is going to go underneath x. So I need to find that value of this case, which is b. Okay. So in order to do that, again, I have that connection that c squared is a squared minus b squared. Again, I don't care about you knowing what is a, what is b. all that matters is the big number comes first, and that big number is the one that deals with where or what direction the major axis lies. So in this case, our value of A is going to be 3. That is the bigger value from the major axis. My value of A is going to be 2 because that's the distance out to the foci. So this gives me 2 squared is equal to 3 squared minus B squared. 2 squared is 4, 3 squared is 9, and then we just need to find B squared. And again, that's exactly what's going to go underneath X, so you don't need to find the value of B itself, you're just looking for B squared, because the equation of our ellipse will be X squared over B squared plus Y squared over 3 squared equals 1. And so if I just rearrange this, you can go ahead and subtract 9 and then divide by -1, or just flip things around. But we get that B squared is going to equal 5. So what goes underneath X is just going to be 5, okay? So this is the equation of our ellipse. Okay. So again, when we start talking about hyperbolas, the same idea is going to come into play. You have to make a distinction between A and B, but it really doesn't matter. It's just the one that deals with the major and minor axes, or the direction that things open up in, okay? So the last thing we're going to do is talk about what happens if we change the center point. So instead of having our center at 0, 0, what if we move it to a different point, like our center of a circle? So the only thing that ends up changing is going to be the equation. So if we move the center to HK, it's just going to change that. So if our center point is, say, right here, you still will need a minor and major axis. Let's see if I do that. Oh, look at that. It actually turned into an ellipse. So our equation, instead of just x squared over something, y squared over something squared equals 1, you now are going to subtract that new center point. Okay. But again, to find the foci, to find the vertices, all you do is move that distance from the center. So you would still, to find the edge value over here, is you would add or subtract that value of A. So in this case, what's under X, because that's our longer axis. But the Y coordinate does not change. To find your foci, same thing. You add or subtract that distance from the center. So your foci would be somewhere along here. So I really do not want to write an equation for each of these values, because all you're going to do is move that distance from the center point. So you add or subtract depending on what is your major or minor axis, okay? So in this case, you would move a distance of B. For the vocal or the center points, you would move a distance of A to get out to the foci, or sorry, C to get out to the foci. And then to get out to the vertices, you move a distance of A. Okay. So again, I'm just going to show two similar examples where we're going to be given the equation and have to find all of the key components and graph it. And then we'll also be given some key information, and then we need to find the equation. So we'll start with the simpler of those, which is just going to be find all the components given that equation. So immediately I can pick off the center here. From X, we're subtracting 2, and our Y is -1. So our center is going to be at 2, -1. So again, I'm going to start drawing this immediately. Okay. Now, if I look at the two values underneath x and y, the larger value is under y, so our major axis is in the y direction. Okay. So all of the key important pieces of information are going to occur in the vertical direction. So to figure out what those vertices are, and then also to figure out where my other endpoints are, for the y, I'm going to move a distance of 4 to get those edge points. So if I start here at -1, I have to go up 4. So 1, 2, 3, 4. That gives me one of my vertices here, which is going to be at 2, +3. So again, the x coordinate didn't change to find that vertex. To find the other, I go down a distance of 4. So 1, 2, 3, 4, which leaves my y coordinate at -5. But my x did not change, okay? Then to find how far I move in the x direction, I look at what's under x. So we're going to move 3 from the center. In x's direction. So we'd go to the right 3, 1, 2, 3, which lands our x coordinate at 5, and our y coordinate stays untouched at -1. And then we go back 3, 1, 2, 3, which lands us here at -1, -1. So that gives us our ellipse. And again, now I just connect those dots, and let's see how well, oh no, won't turn into an ellipse nicely. So you just get my hand-drawn rough graph. Okay, but that is our ellipse. So we have the graph, but again, we need to find all of these things. We do have the vertices, we do have the center. We can find the domain and range from our graph. The last thing to find is the foci. All I do know is they are going to occur in the y direction. So we're going to find the foci. Here, your x coordinate is fixed. It will be 2, but we're going to move a distance of c in the y direction. Again, I got to figure out what that value of c is. In this case, our bigger value of a is 4, or a squared is 16. And then your value of b is 3. But really, again, you just need b squared. So c squared is the larger value in our denominator minus the smaller, giving us 7. But again, because I need the coordinates of the foci, I need the straight value of c, which is not a pretty number. It is √7. Okay. So from my center point, I have to go up and down a distance of √7, which roughly is like 2 point something. So we go up 1, 2, and a little bit. One of my foci will be roughly around here. And then I go down 1, 2, and a little bit. So my other foci is around here. But this distance is √7. And same thing, this distance is √7 to get to those foci. Okay. So we can now write everything down, our vertices. occur I'll start with the formula just so you can see it, but our center for the x coordinate is 2, and what we did in the y direction was we added or subtracted that value that is underneath y. So we added or subtracted 4, which gave us those 2 points of 2, 3, and 2, negative 5. So if you look in your book or if you look stuff up online, it oftentimes will give you a formula where it's HK plus or minus something, but I think it is a useless formula. Just know all of those components and what they mean physically in terms of the graph and create the formula yourself. Don't sit there with rote memorization. For our foci, I don't have nice coordinates because we have to add or subtract this distance of root 7. So again, the x coordinate stays untouched. And then in that y coordinate, we went up a distance of root 7. And then we also went down a distance of root 7. So you can write it as plus or minus, or you can go ahead and write it as 2 separate points, up to you, okay? And then our domain, the x values are trapped between -1 and 5. And then for our range, our lowest y value is -5, highest y value is 3. So this is all of the key information that we need for this ellipse. Okay. So again, I don't like utilizing formulas. I just like being able to connect this to just a method that you use and recognizing, just like our circles, you're going out a distance from the center. So once you have that center point, the stuff that's under x tells you how far you go in x. The stuff that's under y tells you how far you go in y. And then your foci are just going to occur along the longer of those 2 axes, okay? So let's try one more with this one where we are given some key components and we again want to create the equation of the graph. So we're going to find the standard form of an equation of ellipse with foci at 2, -2, 4, -2, and then our vertices are at 0, -2, and 6, -2. So you can see that y coordinate in all of these cases is -2. That tells me that y coordinate's pretty stuck. So everything's probably going to occur in the x direction. But again, I definitely like to draw a picture to get a better idea as to what's going on. So I'm going to start by graphing the key pieces of information. We have to go out 6 in the x direction. And go ahead and label these by 2s, and then we have to go 2 in the y direction. We don't need a full graph of this ellipse, we just need to figure out what that equation is. So starting with our 2 foci, those occur at 2, -2. So here's one foci, and then 4, -2. Then we have one vertice at 0, -2, and 6, -2. So again, all of the major stuff is going to occur in the horizontal direction. So the larger value needs to go underneath x. One thing that is going to be really important is finding that center value. So you can think of it 2 ways. The center has to occur halfway in between the foci because you start from the center and go out an equal distance. Or it occurs halfway between the vertices, either way. So the center is halfway between the vertices and foci. So definitely our y coordinates, -2, that's not changing. But if I go ahead and look at halfway in between 2 and 4 would be 3, and halfway in between 0 and 6 is also 3. So our center point HK is going to be right here at 3, -2. Then I also know my major axis is horizontal. So the larger value goes under x. Okay. So this ellipse has the form x minus the x coordinate squared over a squared, y minus the y coordinate squared over b squared equals 1. And immediately I can replace what h and k are. So x we subtract 3, and then y we subtract -2, so that becomes +2. And I'm going to leave what's under them blank because, again, you really don't need to write this equation. You can jump into it. I know what goes underneath x because starting from the center point, I go out a distance of 3 in each direction. So that means what goes underneath x will be 3 squared. And I don't know what goes under y yet. So again, just going to leave that as an unknown, in this case, b. Again, you can use totally different letters. It really doesn't matter. However, to find b, I do know that my distance from the center to each of the foci is 1. So we're going to need to utilize that to find what goes underneath b. And again, I just need b squared. You don't have to find b itself because I don't need to draw this, so I don't need to know the distance I go up and down. I just need what goes underneath y. So our value of a is 3, our value of c is 1, and then we have that connection. C squared is the larger value squared minus the smaller value squared. So 1 is going to be 3 squared minus b squared. Subtracting 9 gives us -8 is -b squared, which just tells us b squared is 8. So that is what goes underneath y. So the equation of our ellipse is x minus 3 squared over 9 plus y plus 2 squared over 8 equals 1. Okay. So again, go ahead, draw this out, make sure you have everything, all the key components. But these are very similar to circles, just some extra stuff because you have 2 different directions that you're going in.